Okay, the derivative of tan inverse of x, that is equal to 1 over 1 plus x square. I think I should explain you that why it is so. Now, suppose you have tan inverse of x and you put that equal to y, okay? And then your x is going to be tan of y. Okay? And then you differentiate both the sides with respect to x. Okay? So this would be 1 and this would be secant square y, and then you have dy by dx. Okay? There is secant square y. Remember that implicit functions derivatives. The derivative of y is going to be dy by dx. Okay? Achha. So this dy by dx is now 1 over secant square y. Okay? And if you see, if your x is tan y, can we say if we square both the sides, we can say that your 1 plus tan square y is going to be secant square y, है ना? यही होता है ना? That is secant square y. ठीक है? Can I change this tan y with the x? So you can say that the secant square y is going to be 1 plus x square. Okay. So from here you have the dy by dx, that is equal to 1 over 1 plus x square. So that is why we have such a weird integral of tan inverse of x. Okay. So the derivative of tan inverse of x is going to be 1 over 1 plus x square. Okay? So from here, you can see that if you have, for instance, uh, let's say you want to differentiate, you want to see that what is the derivative of tan inverse of 2x. Okay? Tan inverse of 2x. So that will be first of all 1 over 1 plus 2x square, and you will have its derivative over here. That will be 2 over 1 plus 4x square. That is the derivative of tan inverse of 2x. Suppose you want to find, look at these parts here. For example, you look at the f part. So that is, you have to find the derivative of tan inverse of 2x over x plus 1. So this will be 1 over 1 plus 2x over x plus 1 whole square. And then you should have its derivative up here. Like you have the derivative of 2x up here, which is 2. So the derivative of 2x over x plus 1, you can, let me do it here. This is going to be x plus 1 whole square. I'm trying this 2x over x plus 1. I'm differentiating this through the u by v thing, okay? So let me write here, you have u by v. U is 2x and your v is x plus 1. So that is why its derivative is going to be x plus 1 whole square. That is your v square. You have the v square if you need to recall this. Okay, so v is x plus 1 and times u dash is going to be 2 minus 2x into the v dash, which is going to be 1. So when you simplify this, you have 2x cancel with the 2x. So you have 2 over x plus 1 whole square. So this is 2 over x plus 1 square. Okay? If you simplify this a bit further, you will have this 2 over, if I take the LCM here, this becomes x plus 1 whole square plus 4x square. These x plus 1 whole square and this x plus 1 whole square, they will be cancelled out. So you will have eventually 2 over that will be 5x squared plus 2x plus 1. So you got this as the derivative of this tan inverse, this one, tan inverse of 2x over x plus 1. Okay, let me do that tan inverse of x minus 1, the d part. In this d part, you have, okay, for the D part, you want to find the derivative of tan inverse of x minus 1. Okay, so this will be first of all 1 over 1 plus x minus 1 whole square, and then the derivative of x minus 1 is going to be 1. So that is 1 over, it is up to you. If you want to simplify this, you can do that. Okay, so this is the derivative of tan inverse of x minus 1. Look at the e part. You have to differentiate this tan inverse of x square. So this will be 1 over 1 plus x square square, and then you have 2x. That is the derivative of x square. So this is going to be 2x over 1 plus x is to power 4. Okay? And when you have this, if you look at these
Yes,
question
sir.
number two's parts, here you have this tan inverse x within these the products or the quotients. And look at this question number two, part A. You have it here like there is a product going on. Hmm. Like you see, uh, you have to differentiate this x tan inverse of x. Okay? So the derivative of x is 1, and you keep that tan inverse of x with this, and then you keep x as it is. The derivative of tan inverse of x is going to be 1 over 1 plus x square. So its derivative is going to be tan inverse of x plus x over 1 plus x square. Okay? Look at the b part. You have to differentiate tan inverse of 2x over x. So you will be applying the u by v thing. This is going to be x squared, okay? And x as it is. The derivative of tan inverse of 2x is going to be 2 over 1 plus 4x squared minus the derivative of x is 1, and this comes as it is. Okay? So you can write it as 2x minus 1 plus 4x squared into tan inverse of 2x whole over x square into 1 plus 4x square. So guys, that is how you differentiate the tan inverse of x. Now it's your turn. You practice these questions. Okay, these are from exercise 8a. Okay, and then I'll tell you how to uh, go for the integration involving tan inverse of x. So 2c, we have to differentiate this e raised to power x, and then you have tan inverse of x with this. So this will be done through the u dot v. So e raised to power x derivative is e raised to power x, and I keep that tan inverse of x with this. And then plus e raised to power x, and the derivative of this tan inverse of x is 1 over 1 plus x squared. You can take e raised to power x common here. So this is tan inverse of x plus 1 over 1 plus x. We can leave it up to this. Is it different at the back? Hmm? Yes, Walid?
Yes, sir.
It is different. Okay. How much different is this? Have they taken the LCM here? Hmm? Okay. Anyhow, this one is 100% correct and acceptable answer for this. And then you can see it says find the equation, the tangent of the curve. You can try this as well. Okay, let's do this third question. It says find the equation of the tangent. You have to find the equation of the tangent for the given equation. Okay, so first of all, let's see that what is that point. When your x is 2, this becomes y is equal to tan inverse of 2 over 2 becomes 1. And you know that tan inverse of 1 is going to be pi by 4. Okay, so this y is going to be pi by 4. So you have now the point is 2 comma pi by 4, at which you have to write down the equation of the tangent. Now we find the dy by dx, that is going to be 1 over 1 plus x over 2 whole square, and then you have its derivative half the derivative of x by 2. And let's put x2 here. Rather simplifying it, you just put x2 into this, so that will be the gradient over here, that is half over 1 plus 1, and that is going to be 2. So this is 1 by 4. Now this is the equation of the tangent. The equation of the tangent is going to be y minus pi by 4, that is equal to 1 over 4 into x minus 2. You can leave it up to here, or if you want, you can simplify this. This would be 4y minus pi, that is equal to x minus 2. And you can write it as 4y is equal to x plus pi minus 2. So that is the equation of the tangent where your x is 2. So guys, that is it from this differentiation of the tan inverse of x thing. Next, I'll tell you inshallah about the integration which results into this tan inverse of x.